morning, everybody, and welcome to another Breakfast by the Bay. My name is Captain Megan, and behind the camera today we have Miss Reagan. We hope that you all had a fantastic weekend, and again, thank you for joining us for Breakfast by the Bay. So today, as you can see, we're going to be talking all about water, and then we're actually going to get to do some experiments with water as well. So we're just going to wait just a few seconds as people start to tune in so that you guys can see all about water and our experiments. Now, it's okay if you don't have any of the materials for these experiments. You can watch me go through them and then try it by yourself later. Awesome. All right, so I just got a nod from Miss Reagan that we have some people viewed in. So we're going to start talking all about water. So what I want you to think about first is your everyday life and all of the water that you use, right? So water is super important to all of us, not only for us humans, but also for all of the plants and the animals as well. So again, my name is Captain Megan, and we have Miss Reagan behind the camera, and welcome to Breakfast by the Bay, and we're going to start talking all about water. So, what I want to point out first is that water is a transparent, tasteless, odorless, and almost colorless chemical substance. So again, start thinking in your head the day about your normal day and all about how you use the water. I know this morning I got up and I showered and I brushed my teeth and I already drank a glass of water today. So thinking all about all that water you use in your life. Water covers about 70% of our planet, so not only important for our everyday life, but most of our Earth's surface is covered in water, so it's everywhere. So now we're going to get a little sciencey. We're going to put on our scientific hats, and we're going to start talking about water molecules and its chemical formula. So a water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. So you may have heard of water referred to before as H2O. That's water's chemical formula, which just means that we have 2 hydrogen atoms and 1 oxygen atom. And knowing water's chemical formula is going to be super important in just a second when we start talking about the different properties of water. So again, if you are just joining us, my name is Megan, and we have Reagan behind the camera today. Welcome to Breakfast by the Bay. And we are going to start talking about the properties of water so that we can do some experiments in just a few minutes. So, there are 3 different properties of water that I want to talk about today. The first one is this word right here. This is adhesion. And it means that water molecules are attracted or they stick to other substances. So you can kind of think of water as sticky and it wants to climb or walk through with other substances. Our next one is cohesion. Cohesion is the attraction of molecules for other molecules of the same kind. So remember how we learned that the chemical formula of water is H2O. I drew some water molecules over here. So as you can see, we have 1 oxygen atom and it's 2 hydrogen. And what happens with cohesion is that these hydrogens are attracted to each other. Remember, cohesion is the attraction of the molecules of the same kind. So we have these hydrogens wanting to bond together, and they create what's called a hydrogen bond, which we're going to get back to in a second when we start talking about surface tension. So surface tension is an effect where the surface of a liquid can be strong. Now think in your head about our surface tension. Maybe you've seen a bug, maybe a little bug walking across the water before, and that's all to do with surface tension. So I drew a picture over here to help us understand surface tension just a little bit more. So if you can imagine, this is Captain Megan's glass of water, and all of the orange right here are all different water molecules. So what I have right here is this water molecule is getting pulled in all different directions because all of the hydrogens want to make those bonds. They want to have that cohesion happen. But when we look at the top of the surface, those water molecules are a little bit more free. They don't have any water on top of them, pulling them in different directions, so they can create stronger hydrogen bonds, which allows the surface to support a certain amount of weight. So, with our properties of water, of adhesion, cohesion, and surface tension, we are going to do some experiments with them. So we're going to come over to this table. And again, if you are just joining us, my name is Megan, and we have Reagan behind the camera today. We just learned all about the different properties of water, and we're going to start to do some experiments with it. Now remember, if you don't have these materials at home, that's okay. You can watch what I'm doing here, and then you can try it at home later, and you can even rewatch the video to see what was happening. So the first thing that we're going to experiment with is we're going to experiment with that cohesion. So remember, cohesion is when the water molecules like to stick to one another. They're creating those hydrogen bonds. So what you need for this experiment is you need a cup of water, you need a penny, and you need a pipette, or maybe even an eyedropper, or maybe if you have some medicine at home with a little dropper in it too, and your parents say that's fine to use, those are all good things. If you don't happen to have a pipette or an eyedropper, that's okay. You can just use your finger and dip your finger into the water, creating your own droplet. So, what we're going to experiment with is we're going to see how many drops of water we can fit onto a penny because of that property called cohesion. So what you're going to do is you would just fill up your pipette, and then you're going to slowly start to put the water droplets on your penny. And of course, counting how many you can get on there. And you can go fast or slow. You can hold your pipette close to the water or far away, and you can see what makes a difference. Now you can see earlier, I started to do drops on a penny, and you can see that all of those water molecules are being held closely and tightly together so that they don't spill over. And your goal is to keep trying to see how many drops you can get on a penny before it spills off to the side. So that is our cohesion drops on a penny. Now you can see that I have other things lined up here as well, because as scientists, we like to do different kinds of experiments. So not only can you try drops on a penny, and you can do it several times too. And like I said, you can try doing really slow drops on it or fast. See how high your hand is to that penny. But you can also take different things. So I have all my other coins here, and of course they're different sizes, so that might play into how many drops I can get onto those surfaces. And then I have some bottle caps here as well. And those are definitely bigger and shaped a little bit differently. And you can see how many drops you could get on those as well, with all of those hydrogen bonds sticking together. And because we are scientists, we have our scientific hats on today, we can also record our information. We can record that data that we're collecting. You can even maybe create a table and say what item you're using and how many drops you got on it as well. And maybe even put some comments on there saying if you dropped it really, really fast or really slow and how high your hand was it. So that is our cohesion drops on a penny. We're going to move down the table for our next one, and we are going to go back to that surface tension one. So for this experiment, all you need is a bin of water. You could even do this in a cup too if you wanted to. And then you just need some paper clips. So what we're going to try to do with this one is we are going to try to make our paper clip float. As you can see, Captain Megan tried earlier to make sure that I could do it because it can be a little challenging. But I have a few tricks for you to try to see if we cannot break that surface tension that we talked about. So one trick that I have for you is you can take your paper clip and you can bend up the end just a little bit so that you kind of have a handle for it. And then you can slowly and carefully place it on the surface of the water, making sure that you don't add too much weight to it so that it would sink. Now, if that's too easy and you get that and you want a challenge, you can take another paper clip without that little handle and you can try to make it float and try not to get your fingers to break that surface tension. Oh, and if you don't, you can see that it definitely does sink. right? Because I broke the surface tension. I'll try one more time. I have a bigger paper clip now, so it's a little bit heavier, but it still works, right? Because I'm making sure that I'm not breaking that surface tension. So some fun experiments you can do with that one, with your paper clips. Oh, our lights went off again. All right, I'm back. All right, so we have our paper clip float. Now the next thing that you can do is you can grab some tin foil. And with our tin foil, we can see how many times we can get it to fold before it sinks. Now what you can do, if you have maybe a sibling or somebody else, maybe a parent at home, and want to kind of turn this into a little bit of a competition, what you can do is you can make sure that each square of the tin foil that you cut out are the same size, so that you're both starting with the same materials. And what you would do is you would just place it on, make sure that it floats, and then what you can do is you can start folding it. So I would fold it, I'm going to fold it twice right off the bat, because I think that it's going to still float with that. And then you can experiment folding it different kinds of ways and see if that makes a difference. But you can keep folding that tin foil and see how many times and how small of a piece you can get before it sinks to the bottom. I think that was 5 fold. I got 5 folds. See if you can beat me at home. Now, also, too, that was a pretty big piece of tin foil. You can also try a smaller piece as well, or you can try even a bigger piece and experiment with different sizes like that.
So we have one question.
Sure.
Chris wants to know, can the water hold a lot more paper clips?
Yeah, so I think so. The water can definitely start to hold more paper clips as I get it. It's all about still holding on to that surface tension, right? As long as those hydrogen bonds on the surface aren't broken, then you can make those paper clips float. No one's gonna sing. All right, thanks, Chris. So for our next one, you can use tin foil again, and if you want to, you can even reuse the one that you folded up. So you can unfold it and you can make your own little boat. And your next experiment can see how many paper clips you can put in your boat before it would sink. Now you don't have to use just paper clips. You can experiment with different objects as well, seeing how many different coins you can get in before that boat starts to sink. Just another fun water experiment. Awesome. All right, we're gonna move over to our last one. So we talked about cohesion, we talked about surface tension, and now we're going to start talking a little bit more about that adhesion that I introduced to you before. So remember, adhesion is when water likes to stick to other things. So what you need for this experiment is you need a couple different cups of water and maybe one empty one. Now you don't have to use clear ones. Miss Reagan and I just found some clear ones so that it's easier for you to see. You can use any glass or cup that you have at home. You're also going to need some food coloring and then some strips of paper towel. And what you're going to do is you're going to take your food coloring and color your water. You can make them fun colors too. Whatever you want. Don't start mixing the colors yet. We definitely want to keep these colors separate because we're going to see adhesion at work and see if we can actually change the colors in here. So I'm just stirring them up. You can use a spoon or anything you want. Swirl them around. Then what you are going to do is you are going to make bridges with your paper towels. So I'm going to bridge the red and the blue together. And Miss Reagan, if she gets in there, we can see that water really starting to move up our paper towel, right? It's that walking water, that adhesion and cohesion. Those water molecules are sticking to one another, and they're also sticking onto that paper towel, making it move. And then I'm going to connect the blue and the green, and I think the same thing is going to happen. And then the last one I'm going to do is I'm going to put a paper towel from the green into my empty cup on the other side. So now this experiment takes a little bit longer, and you can certainly time and see how long it does take. But if Miss Reagan wants to move on over here, you can see that we set this experiment up just a little bit earlier today. And you can start to see, especially with the blue, all of that water is starting to move into the red side. You can really clearly see that that water is trying to make its way into the other side of the cup. Same with the blue and the green. And when we come over here, you can really see that that green walked all the way up the paper towel and is starting to drip into my empty cup. Now, as scientists, there's a lot of different recording that you can do with this experiment. You can see how long it takes for maybe the cups to become even, to get that water to the other side. You can record and see how long it takes to get these different cups to change color. You can also experiment with the different water levels and see if that makes a difference as well. But with all of these experiments, we're talking about cohesion, adhesion, and that surface tension. So I hope that you guys had a lot of fun with these experiments today and learned a little bit more about those special properties of water. Thank you for joining us, and if you are enjoying these Breakfast by the Bay videos and are interested in supporting and helping out with Save the Bay's ongoing work, you can click in the link below, and we hope to see you back here tomorrow at 10 o'clock for another Breakfast by the Bay. Bye guys!